Love your nearest neighbor. Nearest neighbor methods are incredibly useful. So we shouldn't underestimate nearest neighbor methods. Despite their simplicity, they've been very successful in a large number of problems. Unsupervised nearest neighbors is the foundation of many other learning methods, like manifold learning and spectral clustering. In some sense, all of machine learning can be thought of as being derived from nearest neighbor relationships. In fact, nearest neighbor methods are ubiquitous. Much of what we call machine learning is based on nearest neighbors. Nearest neighbors are also often the first model or the initial model. They're decades old, they're highly reliable. Many industrial, like robotic arms, are trained using nearest neighbor methods, used for classification, regression, much more. They're intuitive, they have high complexity and low bias. Now, they're also an algorithm. Nearest neighbor methods are a function, but there's more than one way to define a function. We've seen how to use an equation model, like the logistic model, but nearest neighbors is an algorithm model, where instead of input and output, we have an argument that produces a return. So for only one return for each argument. Nearest neighbors, suppose you have data points, and for each argument x, you return the closest point among those data points. So the content and goals for this module, we want to introduce similarity-driven nearest neighbor methods and graphs. The 5 videos and associated notebooks will introduce and explore similarity kernels, introduce nearest neighbor networks and their applications, discuss limitations and issues in k-nearest neighbor methods, explore nearest neighbor classifiers and regressors, and introduce the very important concept of recommender systems and collaborative filters using nearest neighbor methods.